Welcome everyone, I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 33, which is search in rotated sorted array. Let's see the problem description. There is an integer array nums sorted in ascending order with distinct values. Prior to begin passed to your function, nums is possibly rotated at an unknown pivot index k, which is uh, greater than equal to like 1 and less than nums dot length, such that the resulting array is this, and this array is zero index. For example, this is a sorted array. It is not rotated yet and might be rotated at pivot index 3, and so that the after rotation, this will be the rotated array and we will be given this kind of array. Now, given the array nums after the possible rotation and an integer target, return the index of target if it is in nums, or -1 if it is not in nums. You must write an algorithm with big of log n runtime complexity. So by seeing the time complexity, you can imagine we have to solve it by some kind of binary search, because we can't solve it in big of in like linear time, because that will be very easy. Just loop over the array and see if the element is present or not. If the element is present, return that index, and if the element is not present, then return -1. That will be very much easy, but we have to solve it in big of n time complexity, log n time complexity, right? And let's see the constraints. The length of the nums will be up to 5000. Each of the element will be from -10 to the power 4 to +10 to the power 4. All values are unique. We have to keep in mind this point. All values are unique and the array will be sorted and rotated at some given index. And nums is ascending order array possibility, and these are the target value would be this. So we will use binary search, but a slightly two-state binary search. So let's start. I will explain the algorithm alongside when I am coding. So initially int n is nums dot size, and in binary search we have to start from the leftmost side and the rightmost side. So two pointers we need. So let's say L is 0 and R is n minus 1. Now, while L is less equal to R, when L is less equal to R, first we need the mid index. Let's say mid is L plus R minus L divided by 2. This is the mid. So first it's simple check. If nums of mid is equal to target, then we need to return that index mid. Okay. Otherwise, two conditions, else if nums of mid is greater than target, or in simply we can say that target is less than nums of mid, and else condition will be this is target is greater than nums of mid. Okay. So now we have to check the conditions. So in this else if statement, the target will be less than the nums of mid. So let's say this is the our given array, and the target will be less than nums of mid. So let's suppose we are standing at index this 7, and the target, let's suppose 5 is the target. So target is less than our mid, but we have to check two conditions, because as the array is rotated, so if target is less than the our nums, so we have to check two conditions. If the rotation made before the current index, which is mid, before that index, or after that index. Because if the array rotation occurred before the our current index, means before mid, so that means our target value will always be left side of our current index. But if the rotation made after the current index, that means we have less values which are less than the current index in both the side. In left side also we have less values, and in right side also we have less value, so we need to check in which side we have to find the next iteration. So for that we need to check that, because if the occurred like the break occurred left side, then we know that the target value will be left side, but if it occurred right side, then we need to check the condition. So first we need to check if the break occurred in right side. To know that, as the all elements are unique, so we just need to check one condition: if nums of r is the last value of the current like you can suppose the uh, subarray. So the current subarray last element is nums of r. If it is less than nums of mid, if it is satisfied this condition, that means the break, like the rotation break, occurred right side of mid. Then we need to check if the target value is present in that part. To know if the target value present in that part, we just need to check if nums of r is greater than equal to target. So let's suppose target value is 0. So target value is 0 and we are suppose we are standing at like index 7. So we will check that if 2 is greater than or equal to target. That means we will know if the condition satisfied that the target value will present in the subarray right side of mid. Okay. Then we will just shift, like for the next iteration we will check the right side of mid to know that. So bring the left pointer at mid plus 1, and otherwise else bring the right pointer at a mid minus 1. Mid minus 1. That's it. This will be the condition, two conditions for if the target is less than mid. Now if the target is greater than mid, then also we have two conditions: the breakpoint of like rotation happened before or after mid. So if the rotation happened after mid, for that, if target is greater than the current value, that means if the rotation happened right side, that means we always have, like we always found the target value right side of the mid if the rotation happened right side, because after the rotation all the values will be less than our current value, and only there could be some possible values in the right side which are greater than the current value. For suppose we are standing at index 5, that means, and the breakpoint occurs at this point like 0, 1, 2. So all the values after the breakpoint like 0, 1, 2 will be less than the 5, and only some values will be there at the right side which are greater than the current index. So target will be right side. That is easy part. But for example, the current index is 1 and breakpoint happened in the left side, and we need to search for greater value. So there are two possible, like in the left side there are also greater values and in right side also greater values. So for that we need to check both the sides. That means we need to check if the breakpoint happens left side. To know that if the breakpoint happens like left side, we need to check if nums of mid nums of mid is less than this first value or not, because all the values are unique and it is sorted and rotated, so this value will always be less than the first value. If it is, that means the like breakpoint occurs left side of the mid. We need to check if nums of mid is less than nums of left side is L. Then we need to check if target is present in that subarray or not. So to know that, we need to check if nums of L, if it is less than equal to target or not. Less than equal to means, for example, this is the current index and we are searching for 6. So we need to check if 4 is less equal to 6 or not. If 4 is less equal to 6, that means we will find our target value in this subarray. Okay. So for next iteration, we will find in the left subarray. To find in left subarray, R will be mid minus 1, and else the L will be mid plus 1. Okay, these are the conditions and we fulfill both. So all the conditions, like target is equal to, target is less than, and target is greater than. So after the while loop we need to return minus 1, because if the value is present, it will already be returned by this condition, and if it is not present, then we need to return -1 as the question says. So let's see will it work or not. So it is accepted. Let's submit it. So it is accepted. So let me discuss the time and space complexities of this algorithm. So the time complexity is big O of log n because we are using binary search, a slightly twisted binary search. So the time complexity will be big O of log n, and space complexity will be big O of constant because we are not creating any array or list which is depending on the length of our given nums. We are just using some variables. So our space complexity will be big O of constant, or you can say big O of 1. So that's it for today. If you want to check out the code, you will find it in the description box below. So that's it for today. See you in the next video.